input-output analysis of embodied energy security. For some background, embodied energy is the sum of all energy used to produce a commodity. Models of embodied energy have helped us better understand the sources and sinks of emissions and energy. This is a figure from a study that found that China was a net exporter of emissions, while the US and Europe are net importers of emissions. The mechanism driving this result is that energy-intensive manufacturing sectors in China will export embodied energy out. Most literature on embodied energy has been viewed in the context of emissions and materials cycling. However, embodied energy is also crucial for understanding energy security. The two key pieces of energy security are to reduce import dependence and increase portfolio diversity. But this definition is for direct energy, not for embodied energy. When a country produces a good or service domestically, it's using domestically produced energy. When a country exports manufacturing abroad, it is reducing domestic energy demand while relying on foreign energy systems. In the first slide, I presented the study that found that embodied energy is largely sourced in manufacturing-intensive countries. However, energy flows don't start where energy is first consumed, but rather where energy is first produced, and this link is missing in many models. So the motivating questions of this study are, is embodied energy security different from direct energy security? Where do we see the largest gaps? To answer these questions, I developed HOMES, or the hybridized option for modeling input-output energy systems. The most widely used method for understanding embodied energy is input-output analysis. Input-output analysis works by representing an economic system through a matrix in which each cell represents the input required from a row sector to produce one unit output from a column sector. HOMES applies a subset of input-output, which we call the hybrid input-output approach. In a hybrid input-output approach, physical energy flows are included in the underlying matrix representation. It's hybrid because they're mixed units. HOMES includes 136 countries, 26 non-energy sectors, and 13 energy types. This means that we're solving for over 562 million unknowns for 1995 to 2015. This requires lots of data. And compiling these data was a large part of this analysis because I wanted to make sure that the model remains open access and thus used publicly available data. I first want to compare HOMES results to existing models. In the left figure, or existing models, China is the major energy exporter in the global economy. HOMES shows a more complex picture. The Persian Gulf region is a large energy exporter, as are West Asia, Oceania, and Latin America. China is a major energy sink. In addition, many countries are linked to energy exporters beyond their direct trade network. For example, a major energy input into the US comes from Russia, even though these two countries don't directly trade energy with one another. And this is because Russia exports energy to Europe and China, which then produce goods and services that are exported to the US. 23% of the global embodied energy network is comprised of these linkages. This means that these countries cannot preemptively implement policy to secure energy linkages because they don't know where they're linked. Here on the left, we see that embodied import dependence is higher than direct import dependence. On the right, we dissect this further. What I want to highlight in this figure is the gap between direct and embodied energy import dependence. The greatest gap is in North and Central America, where embodied import dependence is 45% greater than direct import dependence. East Asia has a relatively low gap because both types of import dependence are high. Where the difference is greatest is in regions that have abundant domestic energy resources sufficient to meet final direct energy demand, but rely heavily on imports of goods and services that require globalized supply chains. And this can lead to a false sense of energy security in these regions. The other piece of energy security is portfolio diversity, here measured using the Herfindahl-Hirschman index, which is the squared fraction of either imports or exports in fuel E going from nation I to nation J. Basically, a higher HHI means that you're less energy secure. Here I'm showing the major energy exporters and their HHI. The high HHI in Canada and Kazakhstan are largely driven by uranium exports. Kazakhstan was the largest uranium exporter, followed by Canada in 2015. But uranium can only be used through electricity generation and requires that the importer relies on nuclear power generation. However, it's not like HHI varies by energy type. There's variation within energy type as well. And the case in point here is crude oil. Saudi Arabia has a low HHI because it exports to countries in a more balanced way. Venezuela has a high HHI because it sends 60% of its energy exports to just 3 linkages. So here are the conclusions of this study. And if you have any questions, please email me. I'm really excited